Hi, today we're looking at 6.3, which is the graph translation theorem. Translation, if you think back to geometry class, is when you take a graph and you move it around on the graph. So that's kind of what we're doing. We're taking parabolas, still chapter 6. We're going to be looking at sliding them around. And it really ties into two things that we've done already. One, so 6.3, the graph translation theorem. Roman numeral 1, the general equation. This is kind of like the lead up to the general equation. Some of the stuff you really could quite honestly skip writing. But if you think back to chapter 2, we had y equals kx squared. And what we're doing this time around is instead of the k, we're treating it like the letter a. So it's going to be y equals ax squared. Be nice if they could pick something and stick with it. We're just going to go with it from there. But if you think of that, that was a parabola that always had the vertex, the high point or the low point, at the origin. So it either opened up like this if a was positive, or, well, we remember it as though positive people, smile a lot. So looks like the upward facing mouth. Then if it was negative, negative people frown a lot. So then the mouth opens down, but you still have the eyeballs. So that's kind of like one thing that we had in chapter 2 that relates. The other part that relates is going to be in chapter 3 when we talked about lines. That we had the point slope form for a line, y minus y1 equals x minus x1. And that kind of tied into the y equals k times x, which would be a line through the origin. Okay, now to move into the new stuff. So you could write this stuff, you could frantically copy it down, or you really could kind of skip it. But I'm trying to tie it into stuff that you already know because it's going to, in theory, make it easy to remember the new stuff. But the difference between a line and a parabola is a parabola has had our x values squared. So where here we start out with y equals k times x, and we came up with this equation for a line. Now we have to have our x values squared, so let me get rid of those. And I wouldn't necessarily copy this blue thing, but I'm trying to make a point here. So the general equation for a parabola I'm going to put in red. And it's going to be y minus k. So the y value, instead of calling it y1, is going to be k. And m was the slope when we talked about the line. Now we have a. A, if it's positive, parabola opens up. If it's negative, the parabola opens down. It also has to do with how skinny it is. The further a is from 0, the narrower the parabola is going to be. So a parabola with an a value of 5 or negative 5 is going to be a skinnier parabola, opening up or down, than a parabola with an a value of 2. But I digress. Okay, so then x, the variable, goes in the same spot as our line equation. But now instead of x1, the x value we call h. So this here is pretty much the equation for the line, but with h and k instead of x1 and y1. To make it a parabola, we have to have the x value squared. Okay, so the general equation is this here in red. And that's worth knowing. It's going to be on the test. Please learn it. So general equation, y minus k equals a times x minus h quantity squared. And to say a couple things about that, first of all, the vertex, which was either the highest point if the parabola opens downward or the lowest point if the parabola opens upward. Before that was always at the origin. Now it's going to be at the point hk, because h replaced x1, k replaced y1. Then a, like before, if a is positive, so if a is greater than 0, it opens up. And if a is less than 0, if a is negative, it opens down. And maybe I'll write this way at least. So farther a is from 0, so the larger number in the positive direction or further from 0 in the negative direction, the narrower the parabola. So that's just kind of some stuff about the general equation. Really the rest of the notes is really just kind of application of those. So I'm going to then jump over to page 2. And page 2 is really just some practice. I wanted to write out 3 different equations and then identify the vertex, identify which way it opens or closes. To learn that equation, because I'm going to ask you to know it from memory for the test, really would ask that you would write it out as you do the homework. One, like I've preached so many times before, you're more likely to get it right in the homework, but then also trying to multitask. You're also going to be more likely to get it right in the homework, and when you get to the test time, you'll know it, so you don't need to try to cram for it the night before. But this first one then in blue, y minus 7 equals 2, and then parentheses x minus 3, parentheses squared. So I took that, I wrote my general equation right underneath it in black. And now for the vertex before we just said was hk on the last page. So now you can really just kind of copy things down. So the vertex for this blue one, the x value is going to be a positive 3 because it's x minus h. So x minus 3 then tells you that the x value is going to be a positive 3. And y minus k, so then k is going to be a positive 7 as well. Whether it opens up or down, that was a, and a is positive, so this one's going to open up. So that's our first one. The second equation, y plus 5 equals negative 1. I probably should point out, if I'd written this way, just with the negative in front of the parentheses, that messes up some people. But if you had to put a number there, that negative then is going to be a negative 1 times what's in the parentheses. But then times quantity x minus 8, quantity squared. Okay, so now my vertex is going to be hk again. So h is still going to be a positive 8. As it says x minus h, it's always the opposite. Here we have y plus 5. That's the exact same as y minus a negative 5. So maybe switch colors here and try to write over the top. So the same as y minus negative 5. So then my k has to be the negative 5. And with a being a negative, it's going to open down. And further, you could go on and say which one's going to be narrower. The blue parabola would be skinnier or narrower because 2 is further from 0 than negative 1 is. Alright, last one. Last one I kind of messed things up a little bit. I have this y equals 7 quantity x plus 4, quantity squared, plus 3. And if you notice that's not in the vertex form for a parabola, that we have this extra plus 3 over here which is messing things up. So if we wanted to change it to vertex form, we have to get rid of that. And we do that by moving it over to the other side, which then gives us a y minus 3 equals 7, parenthesis x plus 4, parenthesis squared. And now we're nicely in vertex form. I'll practice what I preach and copy down the equation. Y minus k equals a, x minus h, quantity squared. Then that makes it easier to say, okay, my vertex is going to be x minus h, so it's a plus 4, which means it has to be a negative 4 for my x value. And y minus 3, which means it's a positive 3. And this one, with a being a positive 7, is going to open up. So that's it for this first part of the practice. Really the last thing is we just have a terminology issue to take care of. And if I jump over here, so Roman numeral 3 is terminology, and in geometry class you probably called sliding a graph around or sliding an object around on graph paper translation. So then I'll say here a translation means slide. Really we're just moving the object around. Okay. Then to write this, if you think back to geometry class, capital R was for rotation, lowercase r was for reflection. You probably did a capital T for translations. And then you had two things, H and K. The first one is going to be the horizontal movement, which is really the X direction, or the H, comma, and then the vertical, which really then gets into T, H, comma, K. And then for that, so for example, if I'm taking a parabola, if I'm moving it, maybe quick put an example here, if we'll say a move or a slide 3 to the right and 4 down, that would be t. 3 to the right in the x direction would be positive, so t the positive 3. 4 down on a graph, down is always negative, so it would be negative 4. And from there then, I can jump back to my last set of notes where we had these 3 different equations. And maybe I'll try to, that's not going to work real well. Do this eraser bit. Let me get rid of my black equation in here. And get rid of this in here as well. Okay. That just makes it a little easier to see. You probably have something more like that in your notes. Okay, now let's put down what they are. So if we had just had instead here for this blue, if we had just had a y equals 2x squared, we know that would be a parabola centered at the origin, opens up. But now we moved it over 3 to the right and up 7, taking the vertex from 0, 0 and making it 3, 7. So then the new notation would just be t sub 3 comma 7. So let's move 3 to the right, 7 up. And you can copy those same things for the last two. That this one here, which would have been y equals negative x squared if it had been a parabola center at the origin, it's moved 8 to the right, so t sub 8 comma 5 down would be the negative 5. And last but not least, t sub negative 4 comma 3. And that concludes the notes for section 3.